Hi chemistry classes. Wanted to go over some of the math for acid base. We did this a little bit before we went on break, but just wanted to review it, and maybe this will help you out with the worksheets. So, we said pH is kind of a comparison of hydrogen molarity. So it's logarithm-based scale. We take negative log of hydrogen. And we know that the two ions we're looking at are hydrogen for acid, hydroxide for base, and they're always in balance. So the more we have of one, the less we have of the other. We measure hydrogen, but you can do the same math for OH. So if you have a base, do the same math, but you just have to subtract it from 14 to get your pH. So that's how we relate the acid particle and the base particle here. On our straight scale, they relate by a constant, 1 times 10 to the negative 14. So if you know one, you can find the other. Or if we know the pH and we're trying to get to concentration, the opposite of this math is right here. 10 to the negative pH will give you molarity. Remember, the brackets mean molarity. So let's try this for an actual substance. I'm just going to get a sample of my delicious Dunkin' Donuts coffee here. Test the pH. It's running mildly acidic, so that makes sense. This value makes sense. 5.6 for black coffee, so we know there's more hydrogen than hydroxide. All right, so let's use these equations a little bit, see what these numbers mean for us. So given any one of these four values, we can find the other three. For our black coffee, the value we got was 5.6 as the pH. Now we know these two relate by 14, so since they have to add up to 14, then we just subtract and find that our pOH is 8.4. To get from our logarithmic scale to our concentration scale, we just have to do the math backwards. So if we take our P function, concentration is 10 to the negative pH. If you type that out, you get 2.5 times 10 to the negative 6th molarity. Then to get our hydroxide, we can either put that value in here and divide out with our constant, or take 10 raised to our pOH. So either way you do that, you're going to get a value really close to 4 times 10 to the negative 9. I got 3.9 times 10 to the negative 9. And that's the math for acid base.